Hi, good morning, my dears. I welcomes you for the today's session about magnetic properties of matter. Magnetic properties of matter. Let's see what is the introduction. Matter is composed of atoms consisting of positively charged nuclei and negative charged electrons. What is the definition of matter? Matter is composed of atoms which consisting of positively charged nuclei and negative charged electrons. These electrons present in orbitals. The periodic nature of chemical properties or behavior of an atom depends on the number of electrons in the outermost orbital. So here the atom chemical property or behavior depends on number of electrons in outermost orbital. So in outermost orbital, how many electrons are presented? Based on the number of electrons present in outermost orbital, then we can design or we can know the behavior of the atom. So this is about the schematic diagram. So here nucleus is having orbit, electron and spinning nature. We know very well about this one. Every atom is composed of primary particles or fundamental particles, that is electron, proton, neutron. Apart from these particles, there are many particles are present, but mainly we are discussing about these particles only. That is electron, proton, neutron. But here the behavior of atom is only depends on electrons. So electrons will be playing an important role to get the behavior of the atom. So here we already discussed atom is consist of this electron, proton, neutron. Here the nucleus is assumed as combination of proton and neutron. Combination of proton and neutron. In nucleus, proton and neutron both present. Where proton is a positive charged body, neutron is a neutral charge, that means zero charge, does not have any charge. So here proton and neutron both combine together, considered as the nucleus. So the nucleus is situated or present at the center of the atom. At the center of the atom. That means nucleus is consisting of proton and neutron. Around the center of the nucleus, around this nucleus, the negative charge, but that means the nucleus is having positive charge. Around this positive charged nucleus, the negatively charged particle, that means electron is revolving. Electron is revolving. How it is revolving? The electron revolving in a particular path. It is revolving in a particular path. That path is named as orbit. That path is named as orbit. So here the electron is revolving around the nucleus. So the path of this electron is considered as the orbit. So here the electron can be moved with two characteristics, like the spinning nature, that is called a spinning nature. The moment of electron is considered as spinning nature. Here electron is possessing two types of the spinning nature. One is a positive of, the other another one is negative of. So here all the matters are exhibiting magnetic properties when placed in external magnetic field. So here all the matters exhibit magnetic properties when placed in external magnetic field. Nothing. This is for only few of the matters which is having specific nature. Not even human body is not showing the magnetic property. That is just it is discussing under some special cases. Under some special cases, all the matters exhibit magnetic properties. Only some specific condition, all the matter exhibit magnetic properties when placed in external magnet. When placed in external magnet, this is only under specific conditions. Then we cannot say a human body is behaving like a magnet. There is some specific conditions are existing. Based on the specific condition, the matter is exhibited. All the matter exhibit magnetic properties when placed in an external magnetic field. So here matter is nothing but it may be solid, it may be liquid, it may be gas, or any type of the material, any type of the status. Okay. So here how the magnetic property is generated. The magnetic property of matter arises from two sources. It will be arising from two sources. From the two sources, the magnetic properties arise. The magnetic properties of matter arise from two sources. An electron in an orbital motion above the nucleus constitutes a small circulating current. So when electron is revolving around the nucleus in an atom with a particular orbital, that electron is circulating certain amount of current. That electron circulating certain amount of current. An electron in an orbital motion about the nucleus constitutes a small circulating current. It is having certain amount of small current which generates magnetic field. So here when electron is revolving around the nucleus, because of circulating current, it is generating magnetic field. The electron moving in its orbit has an angular momentum. The electron moving in its orbit has an angular momentum about the nucleus. So this is about from the just imagine the Bohr's concept, Bohr's atomic model. The electron moving in its orbit has an angular momentum about the nucleus. So it is having angular momentum. In addition to magnetism due to the orbital motion, due to magnetism due to orbital motion, an electron has intrinsic magnetic moment, and intrinsic angular momentum due to spin. Here it is generating magnetic field due to current. In the similar way, it is also possessing a magnetic moment, intrinsic magnetic moment, intrinsic angular moment. Intrinsic means pure status. Intrinsic magnetic moment and an intrinsic angular momentum due to its due to its spinning nature, it is generating intrinsic magnetic moment, intrinsic angular momentum. So this is about the spinning nature of the electron. So this is orbital angular momentum, spin angular momentum of electron. The central one or the middle one is considered as nucleus. So here this is the diagram. So the orange one is known as a nucleus, which is present at the center of an atom. So here around this nucleus the electron is revolving. The blue one is electron. So here the electron is having two types of the orientations. So that's the reason one is said to be spin up, the another one is said to be spin down. Spin up, spin down. So here these orientation of electron or spin up, spin down electron generating a magnetic moment. Which is considered as IA, where I is current, A is area. So here you can see that one, the magnetic moment generated by an electron you can see there, which is represented by mu, which can be considered as Ia. Then here suddenly I'm asking the question, what is mean by magnet? Somebody is asking, oh, we have settled down. So just we are discussing about these are introductions, but what is the meaning of the magnet? Our topic is about magnetic properties of matter. So we are already discussed about the matter, but the thing is that what is meant by magnet? An object which is producing magnetic field, an object which is for producing magnetic field and attracting unlike poles like north to south, and attracting unlike poles like north to south, and repelling like poles north to north or south to south. An object which is having attractive property or repulsive property and which is also creating magnetic field, that object is defined as magnet. An object which is producing magnetic field, it is producing magnet, which is producing magnetic field, which is attracting unlike poles, which is repelling like poles. So if the material having this type of the properties like attractive, repulsive, creating field, then an object is defined as magnet. So in the previous session we in previous slides actually somebody is asking what is material. So here matter nothing but it is maybe solid or liquid, gas. We have another type of the matter, that is Bose-Einstein condensing particle. So here plasma states also, but here basically we are following only three types of the materials, that is we have super matters also, but here generally we are going to classify the materials into only three types, that is solids. We are generally following these three types of the material, that is solid, liquid, gas. So this is about the matter. Matter is composed of the atoms. The atoms consist of the primary particles such as electron, proton, neutron. Based on arrangement of these particles or based on arrangement of atoms, the matter is defined as solid, liquid, gas. So this is about the matter. So here what is the definition? Definition is nothing but magnetic definition, an object which is producing magnetic field and attracting unlike poles like north pole to south pole, like south pole to south pole, and north pole to north pole repelling, then this material is defined as an object. Here we have a story. This is about the discovery of the magnet. So in the 4,000 years ago, 4,000 years ago, a Greek shepherd named Magnus. This is about the story regarding the discovery of the magnet, how the magnet was discovered. So this is the story. 4,000 years ago, a Greek shepherd named Magnus. His name is what? Shepherd name is Magnus. What is the name of the shepherd? Magnus. So his work is what? Tending sheep. So one day he is tending a sheep in a region of northern Greece. Is a region of northern Greece. So one day he is tending a sheep in a region of northern Greece. So the place in the northern Greece is called Magnesia. In a region of northern Greece, the place name is Magnesia. So in a Magnesia region, this shepherd, his name is Magnus, is tending a sheep. He suddenly found that a particular phenomenon. What is the phenomenon? When he took a step, the nails that held his shoe, the nails that held his shoe together and metal strip were stuck to the rock. So here what is happening is nail and shoe and metal strip. The shoe is having metal strip, so they are using the metal shoes to protect their force in those days, because he is tending a sheep. So what is happened? He found that a particular phenomena When he took a step forward or somewhere, the nails that he held, nails, the nails that held his shoe, the nails that held his shoe together and the metal tip were stuck to the rug. Stuck to the rug means attracted to the rug or holding at the rug when he was standing on. When he was standing on, what was happening? The nails that held his shoe together, the metal tip were stuck to the rug when he was standing on. He was shocked. He was shocked and found what was happening. Then he dug out. He began digging and discovered. He began dug out and finally he dug out and discovered the fossil recorded lodestone. So he dug out a material and he named as a lodestone. So this is about the lodestone which I got from the online. So this is, see, the rock is attracting these clips or these pins. The rock is attracting these clips. See here, it's attracting certain clips. So here, this lodestone were these lodestones known as magnetite. These lodestones known as magnetite, probably named after magnesium or magnesia. Magnesium or magnesia. So this is about the discovery of the magnetic material. So it was discovered by magnesium in magnesia region. So it is called as magnetic material. So it is magnetite is nothing but it is a ferrous oxide material. So it is simply considered as Fe2O3. It is considered as Fe2O3 material. This is about the ferrous oxide material. So this is ferrous oxide material, the magnetite. So this is about the world and history image. This is people are below that his name is Magnus, and that front one is a sheep, and people are below that one is foot, fingers and shoe are stuck to the particular rock. That rock is named as magnetite. People are below it was a history of the magnet. So let's see another section, types of magnets. Presently there are many types of magnets around us, but basically here we are going to discuss few of the important types of the magnets. So here there are basically people are below that one few types of the magnetic materials. Here there are three types of magnetic materials we are going to discuss here: permanent magnet, temporary magnet, electromagnet. Let's see what is the permanent magnet. Permanent magnets are those magnets. Permanent magnets are those magnets that are commonly used. So regular used magnets are called as a permanent magnets. Permanent magnets are those magnets that are commonly used. They are known as permanent magnets. Why they are known as permanent magnets, this commonly used one? Because they do not lose their magnetic properties once they are magnetized. So here the magnetic property won't be lost. The magnetic property remain consistency. There is no losing nature in magnetic nature. So here these regularly common use magnets, why they are considered as permanent magnets? Because the magnets do not lose their magnetic property. The magnet do not lose their magnetic property once they are magnetized. Examples of the permanent magnets: ferrite, alnico. So aluminum, what is alnico? these materials are used regularly in flying objects like in aeroplane devices, aeroplane parts we are using. So here aluminium, nickel, cobalt, aluminium, nickel, cobalt. Samarium cobalt. This is a rare earth element. Samarium cobalt. Neodymium iron boron. This is also neodymium is one of the rare earth metal. So here ferrite, alnico, samarium, cobalt, neodymium, iron boron. These are the few of the examples of the permanent magnets. Let's see another type of the magnet, that is temporary magnet. Temporary magnets can be magnetized. Temporary magnets can be magnetized in the presence of the magnetic field. When the magnetic field is removed, these materials lose their magnetic property. This is known as temporary. In the presence of the magnetic field, they will behave like a magnet. When you remove the magnetic field, they lose their magnetic property. In the presence, they will be act as a magnetic field. In the absence, they will be act as a normal material. So that is temporary magnet. What are the examples of the temporary magnets? Iron nails, paper clips. Let's see. See here, that iron, the paper clips, they are attracting due to an external magnetic field. When you remove the external magnetic field, the paper clips won't be attracted. So this is about in the presence of the magnetic field, they work as a magnetic material. When you remove the magnetic field, they won't be work as a magnet. So this is about the temporary. And another type of the magnet, that is third one, electromagnets. So what is electromagnet? Electromagnet consists of a coil of wire wrapped around the metal core. Electromagnet consists of a coil of wire wrapped around the metal core made of iron. Electromagnet consists of a coil of wire wrapped around the metal, wounded around the metal core made from the iron. So here what is thinking? What is the meaning of this one? Electromagnets are consist of a coil of wire wrapped around the metal core made up of iron. So your metal core is what? It is an iron. When this material is exposed to an electric current, this core material, when exposed to the electric current, the magnetic field is generated. The magnetic field is generated and it behaves like a magnet. The core, whenever it is exposed to the electric current, the iron core, whenever it is exposed to the magnetic field, whenever it is exposed to the electric current, the core is behave as a magnet. So this is about the electromagnet iron core and copper coil wire. This is about the wrapping nature. So here it is whenever it is exposed to the electric current, it shows certain amount of the property, that is magnetic property it shows, then it will be considered as magnet. That's it, a magnet. Let's see another section about properties of properties of magnet. The magnet is exposing many types of properties. It is exposing many types of the magnet properties. But here I'm not going to discuss the all things. Just I'm going to discuss few of the magnetic properties. Let's see what are the few of the magnetic properties. The first one is attractive property, repulsive property, directive property, pair property, show test of magnetization. Attractive, repulsive, directive, pair, show test. So these are the certain properties of a magnet we are going to discuss. Let's see what is attractive property. Magnet attracts ferromagnetic materials like iron, cobalt, nickel. So your magnet is attracts ferromagnetic materials like iron, cobalt, nickel. So iron, cobalt, nickel, these materials will be attracted by magnet, then it is considered as attractive property. It is considered as attractive property. Similarly, the second one is about the repulsive property. Like magnetic poles repel each other and unlike magnetic poles are attract to each other. So this is about the general rule of the poles. Like magnetic poles repel. Like magnetic poles means north pole to north pole or south pole to south pole. These same type of the poles means like magnetic poles are repel each other and unlike magnetic poles unlike magnetic poles are attract to each other, that means north to south, south to north. Different poles will be attracted, same poles will be repelled. Directive property. A freely suspended magnet always points in a north to south direction. So this is about the directive property. What is directive property? A freely suspended magnet always points in a north to south direction. When you are suspending a magnetic material, it always shows north to south direction. This is called as the directive property. Another property, that is pair property. When a magnet is cut into two pieces, both the pieces will have the north pole and south pole. Even if you divide or if you cut into smallest piece, even the smallest piece of the magnet also will be having north pole, south pole. That is the reason it is called a dipole. Magnet is a dipole. So we cannot imagine a magnet with the only single pole, like only with the north pole, only with the south pole. It is impossible to predict magnet with a single pole. Magnet is always existed with the two poles, south and north. It won't be exist with a single pole. So that is the reason magnet is always called as dipole material. It is a dipole, not single pole. It is a dipole. Last property. So test of magnetization. This test is conducted to check if a given rod is magnetized or not. So any material, if it is affected with the magnetic nature, so the affected magnetic nature will be identified this show test. So show test is a test for the identification of the magnetized material. When the material is magnetized or not magnetized, that all will be discussed in the show test of magnetization. In the form of, it may be attractive, it may be repulsive. So if it is showing attractive or repulsive nature, then it is showing that one magnetized. Otherwise, nothing. It won't be. We can say it not magnetized. Then another section about magnetic properties of lines of force. Properties of magnetic lines of force. Magnetic lines of force start from north pole and end at south pole. Magnetic lines of force start from north pole and end at south pole. So here magnetic lines of force start from the north pole and end at the south pole. They are continuous through the body of magnet. So they always move continuously from the body of the magnet. Magnetic lines of force can pass through iron more easily than air. So here the lines of force passing easily in iron when compared to the air. When compared to the air. Two magnetic lines of force cannot intersect each other. The magnetic lines of force cannot intersect each other. Two magnetic lines of force cannot intersect each other. They tend to contract longitudinally. They are contracting longitudinally. They contract longitudinally. They tend to expand laterally. In longitudinally, they are contracting. In laterally, they are expanding. So, this is about the introduction of the magnetic properties of a matter.